2-7. I like when we can do one section a day. It makes me feel like we accomplished something. Like instead of doing like day 1, day 2, day 3.
Yeah.
Sometimes in calculus we spend 4 days on one section. It feels like we're on the same section forever. What?
Not that I was just talking to
Yeah. Don't be a jerk. Okay, I don't know if you need to write this down or not, but when you solve an equation with fractions in it, one thing you can always do is you can multiply through by the common denominator. I wrote an example first that just has numbers as denominators just to remind you. But way back in Algebra 1, like that was a little helpful hint when you're solving equations with fractions in it, that all you have to do to get rid of your fraction is figure out what your common denominator is and multiply everything in that equation by that common denominator, and then voila, you have no more fractions. And it's much easier to solve. So this is kind of some terrible typing that I did, but this is supposed to say 3x over 2 plus 2/5 equals 1/5. And I'm very much aware that we could just subtract 2/5 and then get rid of the 3/2. I'm very much aware of that. The ones that you're going to see on your homework today are going to have x's and like x plus 2 in the bottom. So I just wanted to use this as like a basis to remind us that we can do it. It's your least favorite lesson? It doesn't take forever to do. It's actually, I think you're thinking of adding and subtracting.
I feel like I'm getting
This is not forever to do, I promise. It's fun. Look, he's already done.
that's like a second grade problem.
I do want to point out that if you have x's in your denominator, then your domain is not all real numbers, and you have to check and make sure that your answer doesn't make the original problem go to 0. And not on this problem because we don't have x at the bottom. But what would the common denominator be between 2 and 5? 10, right? 10 would be the common denominator. So I could multiply everything in this problem by 10. Right? Why do you seem so annoyed with this? It's fun. You say 2 goes to 10 5 times, so that's just 15x. 5 divided into 10 2 times, so then that's plus 4. 5 divided into 10 2 times. Oh my gosh, doesn't that look so much easier to solve than all those fractions?
You're going to confuse me so much with that.
Why? All those crossing out?
No, just like...
That went really fast.
Sorry, go again.
No, it's just, you do it. You asked that.
What do you do?
Well, I figured out what you have to multiply by.
Okay. Here, I'll write it out like this. Times 10. I'm going to multiply everything times 10.
Like if it was like 15 and 45, I know that I have to multiply 15 by 2 something like that.
Oh, see, but you're kind of like skipping the math of it. Like you're just making the shortcut.
Well, yeah, because it's easier that way.
I get it. I know you're going to do it, but I'm going to do it the correct way every time. Because what you're really doing, because here's what you're doing. Like, you're saying in your head, oh, I know I just need to multiply by 5 here, right?
Yeah.
And 2 here, and 2 here. But you're really canceling the bottom out when you're doing that, right?
I know, but it's weird.
All right, well, I'm going to do it the correct way. You're going to do your crazy shortcut way.
Teachers taught me shortcuts like that.
And then you can simplify this.
So why 10 is the same as
Because if you were going to get a common denominator between those fractions, 10 is the first number that both 2 and 5 have in common, right? So you could pick a number bigger than 10, like 20 would work also, but we usually try to find the least common denominator, so you don't have to simplify it. So then I just simplified that, and that's where I got the 15x. 5 divides into 10 2 times, so that's where I get the 4. And 5 divides into 10 2 times, which is where I get the 2. And then you just solve it. So I get 15x equals negative 2, x equals negative 2/15. Which we could have done without doing that step, but again, I just want to kind of remind us about fractions and common denominators. But again, like I said, the ones on our homework are going to have polynomials in the bottom, or at least a binomial in the bottom. And we still want to practice getting common denominators doing that. So let's start again, nice and easy here. This one you kind of could do a couple ways. You could make this into a proportion problem if you wanted to, because you could make it like 1 fraction equals 1 fraction. But I'm just going to go the same route I did before. They are fun. They are easy. said it was fun. He said math is fun.
No.
We all heard it. It's on the recording.
I took it back before you said that first.
You could think of this as a proportion because could I think of this as all over 1? If you have one fraction equal to one fraction, it's a proportion, and to solve it, you could just cross multiply, right? Remember doing that? So just a reminder there, if you see that, you can do that. You can only do that if it's just one thing over here, like one fraction. You couldn't do it if there's two things added together. If you want to do it the same way I did the last problem, then you would say the common denominator here, if these have a 1 over them and these have an x over them, the common denominator would be x. And so you could say I could go through and I can multiply everything by x, and that would cancel out my fractions. You're going to get the same answer as if you cross multiply. I'm just going to try to be consistent in my notes here today. So I would get x squared plus 2x, and again, I multiplied by x so that it would cancel out, so I just get 15 over here. No, it's just a messy equal sign. That's tomorrow. Tomorrow's inequalities. How do I solve this?
Factor.
Yeah, it's a quadratic, so you need to do one of two things. You can get it equal to 0 and then factor or do the quadratic formula, or you could complete the square. Most of these should be factorable. I'm not going to 100% promise you there might not be one that's kind of ugly on here, but most of them are factorable, so that's what I'm going to do to solve this. What multiplies give me 15, that subtracts give me 2, positive 5, negative 3. So I get x equals negative 5 and x equals 3 as my answer. Check for extraneous solution. If we go back to this original problem, what value would make this undefined? 0. Did I get 0 as my answer? So I don't have to exclude any of my answers. That's what I mean by extraneous. Like we might get an answer that makes the original problem undefined, so you have to throw it out if you do that. You just want to take the answers you get and make sure when you plug them in the denominator, it doesn't go to 0. And so when I look at this, I know 0 is the only thing that would make it go to 0. Those aren't 0, so I just don't worry about it.
And if there's no x, then it can't be.
If there's no x in the bottom, then there can't be extraneous solutions. But I think all of ours are going to have x in the bottom.
I feel like
Number 1 didn't.
except this was last week, so if there's like 15 over x squared plus 5, there's like a quadratic.
We'll get there. We're building up. We're building up. We started baby.
That's the long part. You're like, no, these aren't ever long.
They're not long. They're still really quick and easy. No. It cancels out. That's why you have to cancel out.
Yeah, but it gets full of top, like x squared minus 3 over like 4x.
Look at my.
Yeah.
Foiling is easy and fun. It's foiling. Fun. This is chapter 9 now for 2. My favorite chapter now for 2. It's not true. I don't think everything. Remember yesterday when I said those were terrible graphs? Remember that?
Yeah.
Oh yeah, you
probably
forget.
still enjoy doing them.
I don't. They're pain. This fun. Yesterday, factoring, one of my top 5 favorite math things to do.
Look at you go, Ollie. Done generally. I didn't say it was hard. I said it was long and annoying.
It's not. Okay, here's the thing. When you're finding a common denominators with polynomials, you cannot separate addition subtraction, right? So when you're finding your common denominator, you have to take each factor unless it appears twice. Like if there was an x minus 3 here and an x minus 3 here, we only have to take it once. If there's an x and an x minus 3, so our common denominator would be x times x minus 3. Don't FOIL it out first, right? Because we want to cross stuff out. So we're going to go through and we're going to multiply everything times x minus 3. Grady jumps straight ahead to knowing what's going to cancel out, and if you do that, I'm okay with it, as long as you're doing it correctly, because he's going to say in his head, well, I know that x is going to cancel out, so he's going to only multiply by x minus 3, right? That's what you're saying?
Yes, I mean, that's
I always show that I'm multiplying everything by the same thing. That's why I can do it.
I still write that, cross that out. Like, I was talking about, like, the numbers.
Oh.
That's why I was confused.
And so then you should be able to go through and cancel out all your fractions. If your fractions don't cancel out, then you've done something wrong. So on this one, I would just be left with x minus 3. On this one, I could cancel out factor sign there, minus 2x. And over here, nothing cancels out, so Grady's going to complain that he has to distribute, and it makes it so terrible.
It's gonna get long. These are bad. It's gonna get a little long.
And so the idea is if you can make your fractions go away, it's not that hard of a problem to solve.
Seriously, but you know it's gonna.
The annoying part is you might make a silly little negative mistake and then you're mad because you got the wrong answer because you didn't distribute or put your minus sign there or add right. This is another quadratic though, which means I'm going to make it equal 0. I like to keep my x squared positive, so I'm going to add x to this side and add 3 to this side. All right, 4x squared minus 11x plus 3. I put the 1x and the negative 2x together to get the negative x. Other questions?
Yeah, can you stop there and as like a factor?
No, we're trying to solve this, which means we want to know what x equals. So we have a couple options. One option is if you hate that factor by grouping method, you can do the quadratic formula. And as long as you work it out correctly, you're going to get the same two answers that I get. Because if you factor this, where you have to multiply the first and the last together and say, well, multiplies give me 12, that adds to give me negative 11, which would be negative 12x plus 1x, right? And then you bring down the 3's. I like to factor, so I'm going to choose this over the quadratic formula, but it's okay if you do the quadratic formula. Just do it correctly.
Could you do the whole,
Completing the square?
No, well that, but the 3 and the 4 and then plus or minus everything.
Oh, where you just make the two parentheses and guess and check?
No, we just did like I don't know, yesterday or like Thursday or Friday. Is where you use the factors of the last number and the factors of.
Oh, yeah. You could do PRZs, I guess, which is kind of silly with the quadratic when we have these better methods, but you could do PRZs. Factors of 3 over factors of 4. Yeah, yeah, you could, you're right. That's not right. It doesn't work. It's not factorable. No, look, this is why you check by factoring. I know, because look. No, because look what happens. I know, he always does the quadratic. No, look, here's why it doesn't work, right? This is why factor by grouping you have to pay attention. Because I thought it worked, but I was trying to get a positive number here. Can I take negative 12 and 1 and get a positive 12 out of that? Can't do it. Dang it, I gotta do the quadratic formula.
What a waste of work. Look at all that space you wasted.
Dang it.
It's like 3 lines of paper.
I have an eraser, so you know, you could just erase it.
Well, but yeah, that just looks like you have
The lesson here is quadratic formula always works. Factoring doesn't always work. That's why other countries do quadratic formula all the time, and they don't worry about factoring so much.
I know at the bottom equals.
What do you get under the radical? Someone heard it. 73. Here's the thing, it's not imaginary, so it's definitely still an answer. It's just an ugly answer. Do we have to worry about extraneous solutions if this is our answer? No, that's definitely not going to make the bottom equal 0, which means this ugly thing is my answer. So it's nice to know they're not all factorable. Also nice to know that you got to check and be careful. It doesn't work. If you try to take a negative out of this, it would make both of them negative, so it still doesn't match up. So I did it wrong. But I caught it at least. I know, that's what happens in math. I think it's why I like teaching math, because I still have to do the problems every year. Still learn something sometimes. Every year when I take the calculus AP exam, when it's released, I learn new things. I don't take it when you take it, but like the following September, they release an exam so that I can see what was on the exam, and then I take it and see how many I get right. It's pretty sad.
Do
I created the answer keys at the end.
You can cheat. I don't cheat. You don't know that. You get a 5.
I do get a 5. I don't know.
You should have a
Alright.
test doctor to make sure you don't cheat, because I feel like you get 5 exams.
So I miss some every time though. I always mark. I have every practice exam that I give the calculus kids, and I mark which ones I miss because then I always tell them after they take one, I tell them which ones I miss, and it makes them feel really good if they got one right that I missed.
That would be pretty good.
Because sometimes I make stupid.
Like with Miss Hodge, that, yeah.
It's nice. Like it makes you feel better. It's like, oh, I knew this, and the teacher missed it. So, sometimes you just make stupid mistakes in math. One time, like I always take the exam and then I make Parker, my son, or my husband, I have them grade it for me because I don't want to see the right answer. I just want to know which ones I missed, and then I go back and I see if I can figure out why I missed it. And one time, it said find the maximum, and I found the maximum on the paper, and then I circled the minimum as the multiple choice. And like I had the answer right there, and then I circled the wrong one. It was stupid. But then I see if I can fix them before I look at the answer.
Does your husband laugh at you when he has to grade your test?
No, he just, usually I just have them go through and I say my answer, and then they tell me if I'm right or wrong. So that's Parker likes to do it.
Wrong.
Factor this, right? Don't leave the denominator unfactored, because if you do, it's going to make the problem gigantic and awful. None of these problems should be gigantic and awful. When you get done with it, you should be left with a quadratic at the most that you can solve. So if for some reason you didn't factor this and you picked this and this as your common denominator, what you have left is going to be a big mess, and it's never going to be a big mess, so that should be a clue that it's not correct. This just has a denominator of 1, so again, my common denominator, these both have an x plus 1, so I don't need to take 2 of them, I only need 1 of them. So my common denominator is going to be an x and an x plus 1. So go through and multiply the tops and see what you get. And if you don't actually show that and you just rewrite it, I'm okay with that. I just like to show you so that you have it in your notes. And I definitely do this on my paper, which probably is not good in terms of grading. But I just squish it up in there. It's a little, isn't it kind of fun to cross things out like that? Nothing? Not fun at all?
You can do that.
No, I don't. We don't get to cross stuff out every day in math.
You could.
You just do a line of the problem and then exit out.
Or you could consider making mistakes and erasing it. And you cross out.
I'm going to go ahead and subtract that 1 over here. Quadratics. There's lots of quadratics on this. I got 2x squared plus x minus 1.
What do you got on?
So here's another option. Again, we could just do the quadratic formula because it always works. Or we could try to factor again. Why do you always drink his water?
Well, that's what we need to learn here.
What are you doing with that?
Drinking his water. Just like borrowing his water. Can't always break off.
Oh my gosh. Green, you better not get 1 drop of water on my floor. I will write you up.
No, don't stick it in there.
Just give him his water back. You take 2 times negative 1, you get negative 2. So now I am subtracting to get 1. I can factor that. I can say that's 2x minus 1x. So I could factor a 2x out and get x plus 1. I can factor a negative 1 out and get x plus 1. So that one does work. So we get x equals negative 1 and x equals 1 half. Checking my solutions, if I plug negative 1 into that original problem, would it make the denominator go to 0?
Yes.
So I have to cross it out. Doesn't work. If I plug 1/2 in there, 1/2 does not make the denominator go to 0, so it does work. That means there could be an answer that has no solution, because if the answers that you get are both extraneous, it could be no solution. Also, if you try to solve it and you got an imaginary solution using the quadratic formula, then you'd also say no solution for that problem.
Accidentally put the wrong numbers. It happened to me the same answer.
All right, here you go, Grady.
Oh,
It's not bad, I promise. It's not. This is as bad as it gets, and it's not bad at all.
I know you factor X, but I understand all you.
So quit complaining. That's the lesson.
It's still wrong.
Really nice is if this factors into these two terms, which means you only have a common denominator of 2 terms. Not necessarily always going to happen, but it happens a lot. Which means you say, well, oh, sorry, I guess I should wait for you to write this down. I'm just so excited to do this problem. What multiplies to give me 10 that subtracts to give me positive 3 does work out to be positive 5 and negative 2. So when you take your common denominator, you just need 1x minus 2, and you just need 1x plus 5, which means although it's a bigger problem, you still don't end up with a giant mess that you have to FOIL a million times.
So can you just take x minus 2 and cancel out the other x minus 2, or do you have to take both of them? You want to cancel it out.
You only have to take 1.
Okay, so I can use x minus 2 to cancel out x minus 2.
Yes. Yes. So when I'm going to do x plus 5 times x minus 2 on each one as my common denominator. I don't need 2 of them because the common denominator is each factor the greatest number of times it appears in each term. There's 1x plus 5, 1x minus 2, 1x plus 5, 1x minus 2. So
Yeah, that's what I mean. I thought I could just take x minus 2 on one of them and then x, but I have to do multiply. That's what I say. I have to take x plus 5, x minus 2. I can't just say
yes, but one of them is going to cancel out every time, right?
right.
And what tends to happen is people kind of see what's going to happen, and that's what I thought Grady was implying earlier with his numbers. What tends to happen is people realize, oh, I could just multiply by x minus 2 here because the x plus 5 cancel. And I could just multiply it by x plus 5 here because the x minus 2 would cancel. Which is okay if you recognize that that's going to happen every time as long as you're doing it. Does that answer your question?
Yeah. Sorry, I said it really.
That's okay. X plus 5, and then over here, although it's really ugly, it all cancels out, so you just get 7. See? Not bad, Grady. So there's a quadratic. Minus 6x plus x. If I subtract 7 over, I will get minus 2. So minus 5x minus 2. Seems like a lot of these have the leading coefficient, something other than 1, so maybe if you want to do quadratic formula, you could do that. Most of them are factorable, but that one example earlier was not factorable. But this one also, you could subtract. What multiplies to give me negative 6, that's going to subtract to give me negative 5 would be negative 6x plus 1x. I think I like it so much because I like the factor, and I like to cross stuff out, and it combines my two favorite things in math. Factoring and crossing out. I really avoid the quadratic formula. So you get so excited to be done with the problem that you forget to check your answers. But you're right, x equals 2 does not work.
I didn't ever put dots on the tab like that. I understand. I can write like last year in whatever classes when we were writing on stuff. I wouldn't touch it. Right.
Did your hand touches it. A lot of times people go to write on this and they touch it with their hand.
No, I mean like
I don't know. There it is. I think that's it. Let's see. Is there another one?
I don't know what I'm spelling.
That's all right.
Like in a book.
Oh, do we want to?
No, no.
In fact, it was kind of not effective.
It's Pride Time Day. We don't have time for check for understanding.
No, but I really think you'll plug something.
No, I just dropped. Oh, it's just the printer cord.
Oh, that's
No, it just goes back in here.
they're calling it never mind mistakes.
Tomorrow is the last section of chapter 2, and it's just adding a little bit more to this. It's solving inequalities, quadratic and rational, and then we'll see. I have a worksheet planned for Thursday and then review on Friday, but
Well, we need debating on it.
when we're gonna have the test.
That was next Tuesday.
I thought it was Wednesday.
Tuesday's the latest it's gonna be.
I'll take Tuesday.
Or we could just skip the worksheet and review on Thursday, test on Friday, but I don't know what after that point.
Are we getting ahead of ourselves here?
Only need that extra day for work.
Did I mention yesterday about the AccuPlacer for the dual credit thing?
No.
Next Friday is the last day that you can retake the AccuPlacer. So I have my little list of scores here for people that could retake that. So I'm planning on Friday to have the laptops in here so that if you want to retake it, that you could retake it. So we probably will have a test on Tuesday. So we'll see. There's a few people. I don't think. Oh yeah. There's a couple people in here that could retake it if you want to retake it to do the dual credit for next semester. Because the trig part of Precalculus will be the dual credit class math 137. So I think there's only 2 people in here that either didn't qualify with PSAT or didn't get the
Second part.
the AccuPlacer score. But you can retake the AccuPlacer twice. Like you can take it 3 times. So I just want to give you at least one more chance in class, and then if you still don't score high enough, you can take it one more time next week if you want to.
See, we can't test that then.
And you can stop recording now. That's okay.
Anyway, we'll see.
Go ahead on Monday.